Okay, we couldn't do number 3 and 4 of the no, so we started on number 3, but we couldn't finish it. So let's do that. All right, you drop the ball from A meters above the flat surface. So here's a flat surface. I'm going to draw a picture. And from A meters, drop the ball. Okay, so it hits the ground and bounces up. And each time the ball hits the surface after falling a distance of h, it rebounds a distance of r times h, where r is less than 1 but positive. So every time it goes from h, it bounces r times h. So that's going to be this distance here is ar. And then goes down and bounces up. Goes down and bounces. And theoretically infinite many times. Ar squared here. And ar cubed. That distance there. Okay, I'll write that here. Cool. Alright, now we are trying to find a sum, the total distance. Is A plus 2 times AR, because it goes up and down, there's 2 times, plus 2 times AR squared, plus 2 times AR cubed, and so on. So now we can do it a couple of different ways. So first way to think about it is, all right, now instead of doing 2 here, I'm going to say A plus AR squared plus AR cubed and so on, plus AR squared plus AR cubed and so on. So I'm adding all of these, right? So I can set up 2 different sum, right, series, one for this top part and the second one for this one. So let's do that. So the infinite sum of the total distance traveled would be up here. The first term is A, so A over 1 minus R. And then I have to add this one. The first term is AR over 1 minus R. And if I combine these, I get 1 minus R over A plus AR, or A times 1 plus R over 1 minus R. Okay, so what else can we do? We can think of this as 2A plus 2AR plus 2AR squared plus 2AR cubed and all the way to infinity, but you subtract A at the end. So what would that look like? So sum here is going to be, the first term is 2A, and the common ratio is R. But then you have to subtract A at the end. Okay, so 2A over 1 minus R minus A times 1 minus R over 1 minus R, and you get 1 minus R in the denominator, 2A minus A times 1 minus R, A plus AR over 1 minus R, which is the same thing that we got earlier. There. So either way, whichever way you want to look at it, you will get the same answer for the expression in terms of A and R. Okay, next question was, a geometric sequence has all positive terms. The sum of the first 2 terms is 15, and the sum to infinity is 27. So let's look at that. Sum of the first 2 terms. So let's let the first term be A, because I don't want to write U1 every time, so I'll just use A instead. So if we say A plus AR, A times R, that would be A times R is equal to 15. Okay, and sum to infinity is 27, so I can write A over 1 minus R is 27. So what I'm going to do is I'm going to solve this for A. And then plug it in here. So here I have 27 minus 27R plus 27 minus 27r times r is 15. And when I simplify, r here, and 27r squared is equal to 15. Okay. These two cancel. Okay, and I'm going to move everything to the right side. So 0 is equal to 27r squared, and 15 minus 27 is going to be minus 12. Okay, so here divide both sides by 3, and that will simplify things. So 9r squared is equal 9r squared minus 4 is 0, and I can factor that 3r plus 2, 3r minus 2, and that means r is either negative 2 over 3 or positive 2 over 3, and the question earlier said the sequence is all positive terms. That means r has to be positive as well, so r is 2 over 3. Okay, now that was part A. How do you know the first term? The first term, I'm going to use the equation. So we're working on B now. A plus AR is equal to 15, but I know what R is now. A plus 2 over 3A is equal to 15, and I have one variable with one equation I can solve now. Well, I'll just multiply everything by 3. 5A is 45, and A is 9. So there you go.